morning, students. My name is Dr. B. Suresh Babu, working as a professor in Mechanical Engineering Department in MBR College of Engineering and Technology, Paritala. As a part of online classes, today my presentation is on is today my presentation is on classification of methods for preparation of FGM. What is FGM? It is functionally graded materials. In the previous class, we have learned what is FGM, how many types of FGMs are available, what is the basic purpose of FGM, that is functionally graded materials, and what are the applications of this FGM, and what is the areas or what are the possibilities that FGM can be available. That means FGM can be prepared as well as FGM can be available in by nature or in the nature. So these are the things we have covered in the previous class. Now the present class concentration or present class aim is in how many ways artificially FGM can be prepared. So that is preparation of FGM methods is the today's concept. Basically, few of these methods are known to you and few are new to them. In this class, the aim is what is the classification for the preparation of FGM. That's the first point. And second point is to learn the methods for the preparation of FGM. Not all the methods. Three methods we are going to learn how to prepare this FGM. I have represented in the diagrammatical manner for a better understanding. And now what you are going to learn are briefly explained in the previous classes also. Try to understand the content. I repeat once again, the aim of the class is to know the classification of FGM methods and to know the three methods how to prepare this FGM. That is, what is FGM? Functionally graded materials. That is the meaning of this one. Then let us go for the presentation of the class. So FGM, if you observe, FGM, functionally graded materials, can be prepared by thin film deposition. That means first one is a thin film. For example, a material is there. On the material, we are going to give a coating, and that coating is going to be very thin. For that purpose, what are the possible methods that can be done here? If you observe that one is called physical deposition. Second one is going to be called as a chemical deposition. In physical deposition, two methods are there. That is vapor deposition methods. Second one is sputtering. In chemical deposition, another two methods are there. That is chemical vapor deposition. Next one is atomic layer deposition. So these are the two methods that are possible. Once again, thin film deposition. In that one, physical deposition is there. Second one is chemical deposition is there. In physical deposition, vapor deposition is there, sputtering is there. In chemical deposition, chemical vapor deposition is there, atomic layer deposition is there. So what happens in a chemical vapor deposition? In physical deposition means it is like a painting. It is like dipping in a sugarcane juice, means that the component will get a sweetness. Like that only, so we can have a physical deposition method. Okay, we'll discuss one by one. Let us go for chemical vapor deposition. It is in shortcut we called as CVD. Is a chemical process used to produce high purity, high performance for solid materials. So by using this chemical vapor deposition, the deposition content will have a high purity and it is going to have a high performance for a solid materials. That means here, second point, if you observe, in a typical CVD process, the substrate is exposed to one or more volatile precursors which react and decompose on the substrate surface to produce a desired deposit. So if you observe, subtract means it is the object that we are going to be coated. So the object we are going to coat it will be called as a substrate, is exposed to one or more volatile precursors. That means the substrate is kept in a one place and it is exposed to various types of races, such that those races have the ability to react with the substrate material, and then it will be try to induce in that material. In this way, if we are going to happen, for this one we need a special equipment and we need a special temperature and we need a specific environmental creation toward the substrate that purely depends upon process to process. In this class, we are purely concentrating on chemical vapor deposition, how it is done. In the coming classes, specifically we are going to take each and every method or each and every preparation process to do this activity. That is the thing to understand here. So one is a classification, an introduction and benefit of this CVD. Next, during this process, volatile byproducts are also produced, which are removed by gas flow through the reaction chamber. So another one is here some volatile products are also produced by products and also produced. That means here the some content present in the subtract will be removed and these are going to be done in a reaction chamber so that the subtract can be done in a good manner. That is the thing to be understand here. So this is about chemical vapor deposition. How it is done? In done is two methods. One is it is exposed to a volatile precursor so that those elemental are going to be come in contact with this one and these are going to be induced into the subtract, thereby the metal is going to perform high purity and high performance to do that function. Second one is during this process a volatile byproduct, it is another way, is also produced which removed by gases. That means for example if you want to purify a material, we can produce a steam and the steam can be passed to that substrate so that it can have a bring a purity that will be happen in a reaction chamber. So how we are going to maintain the reaction chamber, how we are going to maintain to produce a deposit of the metal, it will be another method to method, it will differ. Right now you learn about what happens in CVD and how it is done. Specifically, we can have a method to method preparation in the coming classes. Next, physical vapor deposition method. Physical vapor deposition is fundamentally a vaporization coating technique. Involves transfer of material on an atomic level. That means if you want to deposit a material, that can be done in number of ways. Like painting, we can done in painting also. Nowadays a specific method can be followed to improve the coating of this material, like spray painting can be done, or we can go for brushing, rollers. If this has to be carried at an atomic level, then we are going to be call it as a chemical vapor deposition. That is, CVD is a fundamental vaporization coating technique involving transfer of material on an atomic level. That is the thing to be understand. Next, the process is similar to chemical vapor deposition. Expect that the raw materials are prostitutes, that is the material that is going to deposit starts out in solid form, whereas in CVD the precursors are introduced to the reaction chamber in a gaseous state. Here if you observe this slide, it is differentiating between a PVD and CVD. In PVD, the material itself is in the solid state, but here in CVD, the material is going to be in the form of a gaseous state, while before depositing on the substrate. So that is the thing to be understand here. Next, plasma spraying. So if you observe this plasma spraying, the plasma spraying is the one method for using physical deposition process, that is a physical vapor deposition method. If you observe, a cathode rays is there, plasma gas is there, anode is there, power injection is there, powder injection is there, and the material that is coating is green color. You can observe this one, and last one, if you observe this one, this is going to be called as a substrate. So what happens in this plasma spraying process? Try to understand here. Here powder, this has to be deposited on this workpiece. Try to understand in a general way so that you can have a easy to understand and write in the examinations. This is our workpiece. On this one, green color coating has to be deposited. How this is done? If you observe here, plasma gas we are going to send, and cathode is there, anode is there. With the help of cathode and anode, we can able to produce high energy. We are going to produce high energy, that is we are going to create energy such that that energy can be boost to the powder from this point to this point. For that purpose, instead of producing high energy, this energy has to be sent from this point to this point. In which way that can be done? That can be done by using a plasma gas. As gas is also coming here, it is going to be merging with cathode and anode energies, and thereby it is going to be come and falling on the workpiece. In this method, we are going to inject a powder. This powder is the ultimate aim to spread this powder on this workpiece. So powder can be spread on the workpiece by freehand, by using some adhesives, or by using some coating, by applying different types of adhesives on this one and spraying here. But if you want to get high uniformity and very thin deposition, this method is one of the suitable method. That is, when the energy rays are going to be coming with cathode and anode, and along that one plasma gas is sent, means due to the small aperture, plasma gas try to come out on by this setting. At the same time, powder is going to be coming from here, and these are combinedly hitting this workpiece, and thereby deposit is going to be happen. If you observe, by slightly moving up and down, we can able to have a required level of deposition on this workpiece. That is, wherever you can see green color, that is the deposition layer. The deposition is done by powder. That is the ultimate aim. Powder has to be deposited here. For that purpose, we have used anode and cathode. That is electronic energies. Electrons are try to produce here, and along with the electrons, plasma gas is used so that it can able to send the powder from this point to this point. To have a equilibrium of deposition, this substrate can be moved vertically based upon the thickness we need. Next, this is one of the method. This one is the plasma spray process. If whatever you have observed, that is the plasma spray process is basically the spraying of molten or softened material on a surface to provide a coating. That means whatever we have spoken about powder, that is the ultimate aim to be sprayed on the surface. Material in the form of powder is injected into a very high temperature plasma flame, where it is rapidly heated and accelerated to a high velocity. So how material in the form of powder injected into a very high temperature plasma flame. How we are going to introduce it? We are going to introduce it. That means plasma is, it is in a almost liquid, and stage is overcome to gaseous stage. Here if you observe, here high temperature is going to be created. At that point of time, we are going to have the powder. So powder is going to split into number of tiny particles once again, and the tiny particles are rapidly heated to the workpiece with high acceleration and velocity that is generated by the plasma stage. Along with that one, we are going to produce a cathode and anode setting is provided. The hot metal impacts on the surface, on the substrate surface, and rapidly cools, forming a coating. So already I have explained this one. In plasma stage, after hitting the powder on the workpiece, it is going to be cool and it is going to be form a coating. So hot metal impacts on the substrate surface and rapidly cools, and thus completed the coating of the surface. So what we have learned up to now, we have learned about two things. One is classification of preparation of FGM. One is a physical deposition method is there. Another one is a chemical deposition method is there. What is the method in deposition of PVD, CVD have done. So diagrammatically, I have explained about plasma spraying process, how it is done. Next, self-propagating high temperature synthesis. Another method is a self-propagating high temperature synthesis. Here, the aim is to deposit titanium powder on the workpiece. So how it is done? For that purpose, we have taken one workpiece is there. one another supporting material that is called as a lamp black. Titanium powder is mixed with the lamp black. I think you can see the this one. By mixing this titanium powder with the lamp black, this is the mixture which we are going to prepare. This synthetic means we are going to take an one material. We can call it as a dye. It may be halo type, and these are going to be this prepared material is introduced into this halo one. If you observe this one, it is like a shaft, but ultimately it will be like this. And then this is cold pressing, and due to this cold pressing, what we are going to do, without temperature, we are going to done a compaction process. During compaction process, what happens, the material that is mixed here will be present in different forms. It may be distributed like this, or it may be upper one part will be there, another part will be there, or uniformly distributed. It depends upon the amount of material, how we have mixed this within titanium with lamp black. 50-50 means equal distributed. More titanium means more amount of titanium, less amount of lamp black. It depends upon the application of the product where we are going to use. After that one, we are going to remove the material from here, and we have formed a compacted mixture. It is like almost a chalk piece, we can say. So how chalk piece is done, in the similar manner we have prepared here. So compacting is done without a temperature. That's why we will call it as a cold pressing process. After that one, we are going to do ignition. Ignition means it is exposed to the electronic waves. Electrons will be sent, and thereby a chemical reactions are going to be developed, and due to the chemical reactions, the metal still becomes harder, and thereby that harder material is once again exposed to the combustion waves. Combustion waves means what? Here we are going to produce a specific gases, so that the specific gases is passed to these materials. Thereby, whatever the unwanted things are there, that can be expelled from this workpiece. First. Second one is the unwanted gases are going to be removed by these combustion waves. Sometimes these combustion waves are also introduced into the workpiece as they are going to heat, they are going to have a temperature. Due to that one, the material is going to be get high purity. Second, the gases that are going to be react with the titanium carbide and lamp black, and thereby we can able to increase the desired properties what we need. Why? Because the gases what we are going to send will enhance the property of the given. Next, after that one, we are going to get a titanium carbide. It is a material, and that material can be used for a specific purpose. Basically, titanium is a very tough material, hard material, and high strength material. So titanium, if available in powder, it is of no use. That's why titanium is provided with, is combined with lamp black, so that titanium can be used for number of applications. Basically, for the tools, carbide tools will be there. If titanium carbide tools is there, high strength will be there, high hardness will be there, and high resistance will be there for temperature as well as for the impact loads. So like this, we can discuss this process, that is self propagating high temperature synthesis. Here we are going to use synthesis means splitting of the material and compacting and then expose it to this electrification, expose it to the gases, and thereby we are going to get a product. The product is titanium carbide. It can be used for number of applications. So this is about this one. So what happened is self-propagating high temperature synthesis. It is in its usual format SHS is conducted starting from finely powdered reactants that are intimately mixed. So titanium powder is very minutely we are going to use, and at the same time compo black are also used. Next, in some cases reactions are finely powdered, whereas in other cases they are sintered to minimize their surface area and prevent uninitiated exothermic reactions which can be dangerous. So to prevent these unexothermic reactions, we know that endothermic reactions will be there, exothermic reactions will be there. That means energy released in one reactions, energy is going to be absorbed. So these are called endothermic reactions and exothermic reactions. Exothermic reactions releasing the energy. Endo means absorbing the energy. In reactions releasing means it is like a bomb. Next, the synthesis is initiated by point heating of a small part of a sample. Once started, a wave of exothermic sweeps through the remaining material. That means it passes from one end to the other material. That is the point we can able to understand. The synthesis is initiated a point heating of a small part. Usually at the top we are going to turn off the sample. Once started, a wave of exothermic reaction sweeps through the remaining material. That means that will pass from one end to the second end. This will happen in the self-propagating high temperature synthesis. Are able to understand, students? So it is usual in SHS is conducted starting from, so we are going to take material in the form of a small particles, that is self-propagating high temperature synthesis. In short, we are going to be called as a SHS, that is self high synthesis. In this one, propagating and temperatures are the two parameters. One we are going to propagating, and it is going, another one is going to be done at a high temperature. That's why we are going to be called as a SHS. That is the first one. It is going to be done at a very fine powder of two materials. One is going to be called as a titanium powder, which we need, and another supporting metal is going to be called as a lamp black. Next, it is going to be sintered, and to minimize the surface and to prevent exothermic reaction, we are going to do this one. Next, second wave heat generation is we are going to generate heat at one point. Due to the exothermic reaction, it starts from one end to other end. Here we are going to usually start at the top surface. So this is how we are going to done here. So next one is we are going to have a powder metallurgy technique. I think you can visualize this powder metallurgy technique. So this powder metallurgy technique have a four fundamental things. One is powder reduction, pressing, sintering, deformation, machining, fabrication, and quality assurance. So up to this one, we are going for the four. After that one, we are going to machining, and for quality verification, we are going to this. So this method I will teach you in the next class. So before having this one, we can have a brief explanation of this. Powder metallurgy technique is known to you. Try to understand here. Here powder is, this is a powder we have taken, and this is going to be compacted. Here you have a rectangle object. By compacting, what happened? we are going to increase the length and width, and length are going to be controlled, and thereby we are going to increase the dimensions here. That means it is transformed this point to this point. Next, after that one, it will be centered. What is meant by centering? We are going to take a die, and in that die we are going to provide this prepared pressing material, and this pressing material is going to be centered to the respective dimensions, and after the dimensions it will be passed to the rollers. Thereby the dimensions of the workpiece is once again controlled. In ordinary powder metallurgy technique, we up to stage we can able to do it, but after that one also we are going to carry it out in between the rollers, and rollers are going to be control the size of the component. Thereby we are going to do machining process. Here machining is done by drilling process as per observation. Sometimes we can go for the lathe machine. So based upon the required application, we are going to cut into number of pieces, or once again we are going to be machine to bring the quality of the surface, and thereby measuring the surface or measuring the workpiece. This is our vernier calipers, and thereby quality assurance can be done. So sintering is the so in powder metallurgy technique we are going to this one. So sintering is the process of taking a metal in the form of a powder and placing it into a mold or die. Once compact into mold, the material is placed under a high heat for a long period of time. Under heating, bonding takes place between the porous aggregated particles, and once cooled, the powder is bonded to form a solid piece. The solid piece itself is our workpiece, which is ready to use. Try to understand here. Sintering is the process. What we are going to do, we are going to take in the form of a powder. In that powder, we are going to add what are the required material properties for the workpiece. And then it is going to be kept in a mold. That means we are going to get a required size and shape in that mold. Once compacted in the mold, the material is placed under a high heat for a longer period of time. For a longer period of time, we are going to keep that one. So by using this one, we are going to remove unwanted materials, and we are going to bring purity in the workpiece. Thereby we are going to increase the performance. After that one, this process, as powders are very compacted, porous or any gaps in the material or any faults in the material can be excelled or can be removed from that one. And once it is cool means and powder and has formed a solid piece. Thereby the solid piece is useful for the specific applications. So before closing this class, let us have the summary of this one. In the beginning of this class, I have told about what is the main aim of the class. The aim of the class is to know the classification methods of FGM. What is FGM? Functionally graded materials. It is done by two methods basically. Thin coating is done. One is physical vapor deposition method, CVD, chemical vapor deposition method. And I told about three methods. What is a CVD? What is PVD? I have explained. Second, I have explained about self-propagating high temperature synthesis, one method. Before that one, we have gone for the plasma spray process. And third one is powder metallurgy technique. So these are the three methods I have explained. Within 3 to 4 days, I will try to provide the complete notes, As a diagrammatically I have explained, you can quickly remember and you can reproduce. For a specific purpose, that is what is the temperature to be maintained, what is the environmental condition, what is the condition where we have to send the gases. It will be discussed in a process by process. So up to now you understand this one. If you have any doubts, so you can mail to me. The mail ID is cheer5 at the rate of rediffmail.com. So by this I have completed two parts in the syllabus. One is in the beginning of the class I have explained about what is FGM, definition, application and process. Process in the application, classification and how these are available. In the second slide, we have classified what are the methods that are possible for that one. If you have any doubts, we can mail to this one, that is cheer5 at the rate of rediffmail.com. Up to 1, 2, 3, 4 units. It is available in Google Classroom code, that is GMTKRTQ. I am closing, students. Have a nice day. See you all. Bye, students.